So here's a great problem for you graphic design people out there. You've got a poster. So here's the outside of the poster. And inside that rectangular poster is supposed to be 50 inches of printing. And there's a 4-inch margin on the top and the bottom, and a 2-inch margin on the left and the right. So this is 4 inches, and this is 2 inches. And this area equals 50 square inches. So then, if you want to minimize the amount of paper used, well, the idea is with this inside area, you could make it a square with square root of 50 for each side. And then you put a 4-inch margin there and a 2-inch margin there, and you've got your poster, which would end up being a rectangle. Or it's possible that where this, which is all of your printing, you instead decide you want to make it hard for people to read, and you make it 50 inches square by having it 1 inch wide and 50 inches long. So it's the same amount of printed material, and then put the margins around that and build yourself a tall, skinny poster. So the question is really asking which way is going to use less paper, to have an almost square poster or to have a really tall, skinny one. So in other words, these sides could be X, and then you can change X and find out what is most efficient. So you can say that this side down here is X and this side is Y. And then of course we would have the area is 50 square inches, so X times Y has to equal 50 no matter what shape you make, the area has to be 50. But then the problem is asking about the amount of paper used. So the amount of paper used is going to be, well, that's going to be the whole poster. So you need this whole side, which is X, plus 2 inches on that side and 2 inches on that side. So it's X plus 4. Likewise, this is going to be Y with 4 at the top and 4 at the bottom. So that's going to be Y plus 8. So the amount of paper used, P, is going to be X plus 4 and Y plus 8. Well, we need to now combine these two because both of these have to be true. So the way to combine them is, in here, solve for Y, and then substitute that into that one so that we have all of the information into just one function. X plus 4 times a 50 over X plus 8. Now before taking any derivatives and finding a minimum, what I would do is take a look at the graph of that function and make sure that it has a minimum. Because if I just created something that doesn't even have a minimum, then it's probably wrong. So here it is, X plus 4 and then 50X plus 8. For the window, well, I just said, well, what if X was 25? And if it was 25 times 25 for area, that would be 625, so I made this a little bit bigger. And then if you take a look at the graph, it's got a minimum somewhere right about here. So it seems, yes, this is worth proceeding. The way to proceed is multiply this out. So multiply these two, the x's will cancel. Multiply these two, it's going to be an 8x. And then the middle term would be 200 over x. And then we would have this one times this one is a 32. And then take the derivative. So that's going to be 0, that's going to be an 8. With 1 over x, you can rewrite it as x to the negative 1, and then take the derivative, take the derivative. So it's going to be negative, and then x to the negative 2. And then you could rewrite it as negative 1 over x squared. Or you could just skip all of this part and just remember the derivative for 1 over x is negative 1 over x squared. So this will be negative 200 over x squared. So the derivative is undefined at 0, which means something interesting happens at 0. Namely, if this side of the poster were 0, you wouldn't have a poster. So that's not really useful in this case, but you often have to check, what if it's undefined? Next, if it's 0. So move this over to the left-hand side, positive 200 over x squared. And then cross multiply, or basically have these two guys change places. So it's going to be 200 divided by 8. And then take the square root. Usually we would take positive and negative square root, but in this case we only need positive square root of a 200 divided by 8. Very nice. So x should be 5. And then you can substitute a 5 back here to find out that the y should be 10. And that's in inches. So there's the dimensions that should be used. It should be basically, that should be 5 inches, and then this should be 10 inches. So you multiply the two, and that's the 50 inches. That's the most efficient solution.